The Esprit ProfitMilling cycle is a unique patent-pending 2, 3, and 5-axis rough machining strategy. And in the testing that we've done, we typically saw a 70% cycle time reduction, along with anywhere from 5 to 10 times the tool life that we would see with a traditional pocket milling cycle. So how does it work? Well, with traditional tool paths, they needed to be programmed conservatively in order to account for inconsistencies. But the scope of this cycle is to keep the conditions consistent so that variances in the material, part geometries, and machine capabilities can all be kept within the scope of the operation. With the consistent cutting conditions, you'll have a tool engagement angle option, radial cutter offset, and constant chip load on the tool. You'll also have a dynamic feed rate, and the way this works is you set a maximum feed rate inside of the operation, and then the operation will dynamically adjust it up and down to be able to keep a constant chip load on the tool. And the feed rate is also going to be calculated from the tangible edge of the tool, not center line. So we're getting ready to run the new 5-axis roughing cycle using the ProfitMilling tool motion pattern. And we have a piece of 4140 material in the machine with a 5/8 diameter 4-flute ISCAR chatter-free end mill, and we're going to be running at 4,000 RPM and 4,000 millimeters per minute with full depth of cut. The depth of cut is going to vary depending on where we are on the part. So we'll go ahead and start running the cycle now. All 5 axes are moving, meaning that it is a true 5-axis cycle. And then also, if you look at the load monitoring, you can see that there's virtually no load on the machine at all. So ProfitMilling addresses problems that are inherent to traditional milling by offering a tricordial motion in the areas where you have full width slotting, problematic material on both sides of the tool. And instead of taking multiple depth increments, we'll be taking full depth of cut and light radial passes. So we just ended the cycle, and a couple things we want to take notice to is the fact that the part is cool enough to touch. I mean, you can see this tool is very cool. I can even touch it. You also notice by looking at the chips that they're nice and uniform, and they're also discolored, which is a good thing because that means that the heat is staying in the chip and not in the tool and in the part. And the bottom line is, if you're not using this kind of cycle, this high-speed machining cycle, if you haven't already used it, this is a really good opportunity to get into high-speed machining, because of the fact that you're going to have 70% cycle time reductions, 5 to 10 times the tool life. I mean, you really can't afford not to at least try this type of machining. And I think what you'll find is that the load on your machine is going to be a lot less. You'll be running your machine a lot less. Your tools are going to last longer. And it's just a really highly optimized CAM programming cycle to use.